So let us derive another important equation, that is mirror equation. So we have taken here a concave mirror. Suppose AB is the object. So to trace the point, image of the point A, I have taken 3 rays. Actually 2 is enough, but I have taken 3. One ray parallel to the principal axis. After reflection, it passes through the principal focus, and a ray incident at the pole gets reflected by the same angle, and another ray passing through the center of curvature C. After reflection, it traces back, so that means passes through the same direction. So the point where the reflected rays are meeting, so this one, this one, this one, so they are meeting at this point. There you will get image of this point A. This is according to our last earlier discussed for tracing the image of a point. So A dash is the image of A. Similarly, you can trace all the points on this linear object. The images can be traced. You will get the image A dash, B dash. Now, if you observe the figure carefully, so the triangle A dash, B dash, F and F, P, M. So if you draw a normal from M to the axis, it will be somewhere here, very near to P. So that I am dropping here. So directly I am taking that the normal drawn from M to the axis is almost at P. Therefore, this can also be taken as a triangle. This triangle and this triangle are similar. Therefore, from triangles, so that is A dash, B dash, F and F, P, M. Similar, the ratio of similar sides must be equal. Therefore, A dash, B dash by that is MP is equal to, that is FB dash by FP. This is one relation. And similarly, from triangles, here let us take this A dash, B dash, P, this one, and ABP. So here this is same, perpendicular 90 degrees, and here this angle are equal. Therefore, the third angle must be same. Therefore, here we can say that this A dash, B dash, P and ABP are similar. So they are also similar. Therefore, I can write like this. That is A dash, B dash by AB is equal to B dash P by BP. This if you observe these two equations, so if you observe these two equations, they must be equal because A dash, B dash, A dash, B dash. Here MP is nothing but the linear size of the object. So that is MP is equal to AB from the figure. Therefore, I can write like this: FG dash by FP is equal to B dash P by BP. So what is FB dash? Let us see. So FB dash can be written as B dash P minus FP by FP. and that is equal to B dash P by BP. Here we know that B dash P, that is pole to image, that is image distance. Therefore, I will write B, and FP is nothing but focal length. So let us write F, and FP, so that is focal length. And here B dash P, so image distance V by BP, so that is the object distance. So here I am using the symbols. U is the object distance from P to B, object distance, and P to B dash is image distance V, and P to F is focal length. So that is why I have changed this equation like this. And let us try to simplify this. V by F minus 1 is equal to V by U. Let us take this minus 1 to that side. V by F is equal to V by U plus 1. And then we can write like this. V by F is equal to V plus U by U. Now, let us use the sign convention here. So, all the distances measured from the pole, if the distances are measured opposite to the direction of incident ray, they are negative. If they are measured in the direction of incident ray, positive. So, as for this, we can write like this. V, so you have to measure in the opposite direction. Therefore, you can use minus V. And the focal length is also opposite. So, minus F is equal to V. And you have minus V. And the object, it is also measured from P to the, that is also negative. Therefore, minus U by minus U. Therefore, this minus gets cancelled. Therefore, what you get is V by F is equal to, if you take a minus sign outside, here also finally you will be getting the same equation. Even after using the sign convention also, you will get the same equation. Now let us try to simplify this further. So after using sign convention also, you are getting the same equation. So dividing or taking that V to that side, 1 by F is equal to V plus U by V into U. So that is equal to 1 by U plus 1 by V. Because each term if you divide with VU, so it will be 1 by U, this is 1 by V. So that means, finally you can write like this. 1 by F is equal to 1 by U plus 1 by V. So this equation is known as mirror equation. Okay, so remember which triangles you have taken, how the figure is drawn, that is important. The other mathematical derivation is easy. So I have selected 3 rays, one parallel to the axis, another passing towards the pole and getting reflected back, and another passing to the center of curvature and retracing back. So the 3 reflected rays, they meet at a point where the final image is formed. So that is the position of the final image. So I have taken, first of all, I have taken these 2 triangles. So these 2. Considering that P is nothing but almost equal to the foot of the normal drawn from M. So I have taken that also as a triangle. So I applied the property of similar triangles. So by applying that, I equation. So later I selected other two triangles, that is A dash B dash P, this one, and ABP. So this is another triangle I have taken. So since they are also similar triangles, again I applied that property of similar triangles. So what is that? The ratio of similar sides of the triangles must be equal. So that is what I applied. And here I have rewritten this B dash at this distance as equal to B dash to P minus FP. So that is what here I have written. So, and I substituted the symbols for the respective distances. Object distance V, object distance U, image distance V, focal length F. So from this equation I have written this, and then I got this equation. Then what I did is I used sign convention. All the distances must be measured from the pole. If they are measured in the direction of the incident ray, take positive, otherwise take negative. So every term here gets a negative sign. Even after that, you are getting the same equation. Further simplification of this equation, you will be getting this relation. So in this way, we can derive mirror equation. So this is an important derivation, and both these derivations, f is equal to r by 2 and 1 by f is equal to 1 by u plus 1 by v are very important, and they may ask a 4 marks question on this. Okay, so to understand this formula, let us take one simple example. Let us suppose an object is placed at a distance of say some 30 or say some 10 centimeters. Okay, 10 centimeters from the mirror whose radius of curvature is given as so that is 15 centimeters. So let us suppose the radius of curvature of a concave mirror is 15 centimeters and object is set at 10 centimeters. Find out the position of the image and also the nature of the image, and another thing is about magnification. So generally a question will be asked like this, a simple problem. So I forgot to tell you about magnification. So magnification here is nothing but the ratio between image size to the object size. That is called as magnification. So here you can easily understand that n is nothing but the size a dash b dash by ab. So this can be written as some h dash by h. So from the figure you can easily show that this is equal to image distance by object distance. So from the geometry it can easily show that this is equal to v by u, and here you will be getting negative. If the image is inverted, actually you will be getting the negative sign. So the ratio between the linear size of image to the object is defined as magnification. From the geometry of the figure, we can show that this is equal to v by u, and we will be getting negative sign. This negative sign indicates the final image is inverted. Okay, so using this, let us try to solve this problem, simple problem. So object is kept at a distance of 10 centimeters from a mirror, concave mirror of radius 15 centimeters. Find the image distance and also magnification. So use this formula, 1 by f is equal to 1 by u plus 1 by v. So f is nothing but r by 2. So here 15 by 2 is 7.5, and your object distance is already given. Therefore, that is 1 by 7.5 is equal to 1 by 10 plus 1 by v. Here, let us use the sign convention. Since the focal length is measured in the opposite sense, and the Object is also measured. Object is also measured with the opposite direction of the actual direction of the rays coming from the object. So therefore, 1 by v is equal to, bring this to this side, 1 by 10 minus 1 by 7.5. So therefore, finally, v is equal to, so what you get is 10 into 7.5 by minus here minus 10 plus 7.5. So it is just nothing but 2.5. Therefore, this you will be getting it as nearly 30 centimeters with the negative sign, because image is formed inverted, so you will be getting negative sign. Therefore, the image is formed at a distance of 30 centimeters from the mirror. So it is inverted real image and is at a distance of 30 centimeters from the mirror. So that is the image distance. So like this, you can apply this formula to calculate image distances and object distances. Okay, so we will continue in the next class with the refraction of light, and then we will derive lens formula.